quick hi everybody. Thanks for joining the MSVTK webinar, and today I will I'll give a short introduction to MSVTK for the next 20 minutes. I'm pleased to be joined today by two MSVTK members, Deborah Testi from SCS in Italy and Riccardo Ortiz from Kitware, and they will answer any of the questions you may have during this presentation. And because everybody is muted but me, you will be able to ask questions in a questions section in the GoToWebinar control panel. They will answer your question as the webinar goes. So this webinar is recorded, so you will be able to watch it later, and you will be able to find this webinar, the screencast, in the Kitware website and also on the MSVTK website. The slides will also be made available. So with no further ado, let me start the webinar. So today I will go through two main sections. I will give a brief overview of all the demos that are available on MSVTK, and I will also present and demonstrate how you can integrate MSVTK in your application. And finally, I will give some links to summarize a little bit what we have seen today. So MSVTK, the main goal of MSVTK is Multi Scale Visualisation Toolkit. It intends to give solutions to all of the multi-scale and temporal challenges you may face in your application. It's built on top of VTK and Qt, and it tries to keep the same architecture and the same feel of VTK. It just extends VTK. Most of the classes available in MSVTK are good candidates to be integrated into VTK at some point. So if you're familiar with VTK, you will be it will be very easy for you to navigate through MSVTK. So today I'll give a short demo of 4 of the demos available on MSVTK, and on the top of this slide you will be able to see a link to all of the demos, and each demo comes with a step-by-step user guide, and we'll see the link for each of them. So I will start with the VTK buttons demo, and for that I will shift my screen and I will run the application. But first, this VTK buttons demo is about trying to solve the issue with the scale and interaction with it, how to navigate into your data that are on multiple scale. And so these VTK demos, these VTK buttons are built on top of the existing VTK button in VTK, and we will see that there are new functionalities added to these. So all the demos are available in the package of MSVTK that you can download on packages.kitware.com. And so when you run this demo, this first demo, VTK buttons, you will end up with this panel. And I will go very quickly through all these demos to be able to save some time to present how to integrate MSVTK. So the first demo here, we load a pig, the heart of a pig, and then we'll add more into it. We'll start to add some of the fiber muscles that are, both of them are at the organ level. But then what happens when we have data more at the cell level? And this is what happens. So we have all these buttons that are, again, built on top of VTK buttons. And as you can see, they are a little bit enhanced because we can have this Qt tooltip that contains a preview of each of the demo. And the main functionality of these buttons is that you can click on them, and when you click on these buttons, it controls the camera and it can zoom in and out. So you can move from one scale to the other. This is what happened And here what I'm looking at is like the diffusion of the blood flow at the cell level. And so I can easily interact between each of my data that I just loaded, the 3D data. And of course, as you might be familiar with VTK, all of the functionalities usually are wrapped into parameters, so you can control each of these properties. Here I can show, hide all the buttons, and if I click on it here, I uncheck the fly to, so it's gonna directly jump to the data. So that's the first demo, and this work has been gathered into two main classes, the MSVTK buttons and the MSV QVTK buttons, which is a Qt wrapper around this VTK button that adds more Qt functionalities to these buttons. For the next demo, we will present the button clustering. So, in some cases, when you have a lot of these buttons, these annotations, the interface can be a little bit cluttered. So let me load an example. So here on this data, we have a spine volume, and for 5 of the spinal discs, we have generated some of buttons. And as you can see in this view, the view can be a bit cluttered by all the little buttons on the view. So the idea here, I'll just remove the volume so we can see a little bit better. But the idea here is to do a little bit like what Google Map is doing, which is trying to only show a few of these buttons to have a really clean view. This is done by the clustering utility class that we created and we added into MSVTK, where we group all of these buttons based on the distance they are from. So if I zoom in, because the algorithm noticed that there is more space to show all these buttons, it can show more of them. So I think for each spinal disc there are around 10 widgets, and so as you can see, they can be clustered. You can control the radius of the clustering and so on. Another interesting feature is that you have full control over the clustering algorithm. So if you want to, you can cluster through all these buttons, all the spinal disc. And if I show the cluster graph, here you will see how the buttons are clustered. So here for each edge, you see that the button here is a cluster of all the 10 other buttons. So it can be very useful when you want to clear up a little bit your view when you have too many buttons. Let's go back to this page, and you'll see that this entire work is done into the MSVTK widget cluster, which is basically a widget manager that can have full control over the clustering. For the next demo, it's a little bit different. Here is that we are dealing with a large amount of data. We have meshes that are in very high resolution, a couple of million points and faces, and so it can be a little bit too heavy to load on your machine. So the idea here is to load some low level of detail meshes, and we'll see how we can navigate through it. Here. So if I look at the file I just loaded, it's a regular VTK multi-block dataset, okay? And for each tissue, each organ, there is 3 levels of detail that have been generated, okay? And by default, of course, I load the lowest level of detail. So there are 865 pieces, which are tissues or organs, and for each of them, we just loaded the smallest level of detail. As you can see here, there are 946 triangles for this first piece, and I can, on demand, I can augment and change the level of detail. And as I change it, the number of pieces of polygons are increased. That means the file is loaded from cache, the lower resolution is released, and the higher resolution is loaded. So it's an on-demand mechanism for loading data. And to control this interaction, to control this level of detail, you can also do it in a very interactive way. You just click the organ on the view, and here it automatically selects the organ that has been selected, and you can, with the QT menu, increase the level of detail. And as I increase it here, the number of polygons are increased. And so if I zoom in here, you see that the left pectoral is having a better resolution than the right. And of course, I can also hide it here so to see what's underlined. So here what the work was, what was done in MSVTK is to create this composite file series reader that is basically resolution aware, and that offer a nice API to be able to control the level of detail. And finally, for this last demo, I will present some interesting challenge with heterogeneous and temporal data. So here what we have is that we have points that have been sampled on the heart and that have been acquired around along a 2.5 second time period. And so what we created is that we created this widget here, this time player widget, that can be plugged into any VTK demand-driven pipeline that is time-aware. So the role of this widget is to query from any of this pipeline, from the pipeline, what are the available steps, what are the step range, and to be able from user commands to do the request to change the current time. And so you can increase the time, the speed between each of the time steps. So that's one part that has been added into MSVTK. Another one is just to demonstrate how we can represent this time data. And this is better done using the VTK charts. So the VTK charts are wrapped into CTK that are exposed in MSVTK, and they allow you to present 1D data. And so this example, this demo, illustrates how we can integrate these different data, how some are 3D spatial, some are more temporal. And so here's a good example. I can select both of them, and then you have the same feature as what is available in VTK. So let me go back to here. The main widget here is the MSVQ time player widget. And I'll skip the grid viewer for sake of time. And so now what I'm going to do is I'm going to show you how you could integrate MSVTK in your own application. And it starts very easily by just doing a git clone on at the command line. Here I'll create git clone, GitHub. So it's very easy to download MSVTK. See, here I have all the sources. Then I can create a build directory. Here, and then I configure my directory with CMake, and that's it. For more information, if you face some issues, you'll be able to have instruction on how to do that here in the building MSVTK link. So that's it. Like if I do that, if I build, you will see that the MSVTK automatically pull VTK. It needs it. It also automatically pull CTK. CTK is the library that is built on top of VTK and Qt that provides more tools for Qt. So I won't go around all, we won't wait for the entire MSVTK to be built because it needs to first to build VTK, CTK, and then finally MSVTK. So I'll just stop. But now I'm going to show how we can create an application. Let's call it my app. Here. And you'll see on the slide, it's very easy. Okay, I need to be able to copy paste. This file. And of course, typo. I knew it was not looking good. Okay. For the complaint, it can't find MSVTK, so I'll give typically the path you would have built, but in my case, I already built it. And I forgot the main file. So what is done here, as you can see, you only typically need to do a fan package of MSVTK and then you include it. That's all you have to do to be able to use MSVTK in your project. Then if you start to use MSVTK, you need to also specify the MSVTK libraries on top of CTK and VTK. So that's very easy to do. Now I'll just create my file. So it's going to be an application. And I'm going to make it a Qt application. So to be a Qt application, you need to create a Q application. Here. And of course, you need to include the file. And now if I want to use a MSVQ time layer widget, I need to include it. And We won't have any parents, it will be a top level widget. And of course I can also have access to all the classes from CTK and VTK. So just to show it, I can do that. CTK VTK render view is typically a QVTK widget if you're familiar with it. They just come with some utility functions. Here I need to include render view. That's pretty much it. So if I go make and make a mistake, right. I forgot to closing. Okay. And that's the application I just created. So you can recognize the time player widget I was talking about earlier in the ECG demo. Here, that is, of course, we didn't plug it with anything, but typically you will need to plug it into your VTK pipeline. And here is just a simple CTK render view, which is very similar to a QVTK widget. And that's it. So now I just created my application that is using some of the widgets available in MSVTK. And so as you can see, it's very, very easy to use MSVTK. So finally, I'm giving you some links here, and I'll stop here to further extend your discovery of MSVTK. You can go on msvtk.org with all the links. All the demos I briefly, very briefly went through. There is a page here, demo application, that lists all of them and that contains step-by-step guidelines to run through. Some of each of the demos also come with data and some challenges that are associated to this data. So there's a link for that. And of course, there is also the Doxygen documentation for the API of the MSVTK library. And finally, I'll just give you some links to some applications that already use MSVTK. So Gimias is one of them, and so there's a nice YouTube video that demos all the use it does of MSVTK. So mostly it's about the nice buttons and how it controls the camera. And also MAF3 from Italy, from Bologna, are also using MSVTK already. And so you can also see some demos for that. I would like to thank you for attending this very brief webinar about MSVTK. If you have any questions, please don't hesitate to ask them for right now or later on, and you can send them to myself or to Deborah Testi. That you can find the link on the msvtk.org website. And thanks again for watching, and I will stop here. Thanks.